All right, everyone. We are now working on another example from the Trig unit practice test. So same question, where we're determining a solution for each equation on the interval from 0 to 2 pi, given exact solutions where possible, and then we're rounding approximate solutions to the nearest tenth of a radian. Here we have cos 2x is equal to negative 1 over 2. So the first thing that we're going to do is we're going to take, the inverse cos of our ratio of negative 1 over 2. And just plug that into your calculator. Two ways you can do this. You can have it in degrees or radians. It doesn't really matter. I'm going to do degrees for now, just so you can a little bit easily visualize what's happening. So shift cos of negative 0.15, and you get 120 degrees. So 2x is equal to 120 degrees. And at this point, I'm going to draw our diagram to illustrate what's going on. C-A-S-T. We know that this is cos, and we know that the ratio is negative. So which quadrant does the terminal arm have to be in? Has to be here and has to be here. We got angle of 120 degrees, so that's clearly this one here, 120 degrees. So that makes our acute angle in here 60 degrees and 60 degrees. So if that is the case, then our principal angle for our second terminal arm over here is going to be 180 plus 60, because it's 60 degrees more than 180 degrees. And remember, if you're dealing with radians, you can just convert all these values to radians. So 180 would be pi, and 60 would be pi over 3. So it would be pi plus pi over 3, and that's just 4 pi over 3, in case you're wondering. Or 240 degrees. So 2x is equal to 120 degrees. That's one answer. And 2x is equal to 240 degrees is the other answer. So anytime you evaluate a trig function for a ratio, you should get two possible solutions, two possible angles that will give you that value. So if I were to take the cos of 120 degrees, I should get negative a half. If I were to take the cos of 240, I should also get negative half. And if you try that in your calculator, this is true. And remember, you can change it into radians if you want. Sure, I can do change into radians at this point. So 2x is equal to, what's 120 over 180 times pi. And if you divide both the top and bottom by 30, that's going to be 4 over 6. Oh, actually, you can divide both the top and bottom by 60 in this case. So you'll get 2 over 3. 2 and 3. So the answer is 2x is equal to 2 pi over 3. And then x is equal to, divide both sides by 2, obviously, pi over 3. Or 60 degrees. So that is one answer. And remember, if I divide both sides by 2 here, I'll get 60 degrees, so that's the one answer there. 2x is equal to 240, x is equal to 120 degrees. Or if we're dealing with radians, then 240, how do I convert that into radians? 240 divided by 180 times pi. Once again, 60 is a common factor, so that's going to be 4, and that's going to be 3. So this is going to be 4 pi over 3 is equal to 2x. Divide both sides by 2. So x is equal to 2 pi over 3. So these are my two answers. Now, this question is a little bit more tricky, because we've changed our period. What do I mean by that? Well, what's my k value in this example? K value is always the number that's being multiplied with x. My k value is 2. So what's my period going to be? Well, my period is equal to 2 pi over k. And since k is 2, period is going to be pi. Or if you're dealing with degrees, 360 divided by 2, which is 180 degrees. That means this specific function will have 2 repetitions or 2 cycles within a span from 0 to 2 pi. So if you were to graph this, which I'm not going to do here because it's just messy now. But if I were to graph this, let's say down here, what it would look like if this was a regular cos function, excluding any of the other stuff. If it was just cos 2x, you still have 1, still have -1, still have 0. You still start from the maximum. But because it's cos 2x, you'd have 180 as your period, and everything would be halved in terms of like your key points. So instead of 90, it would be 45. Instead of 180, it would be 90. Instead of 270, it would be, what's half of 270? 135, yeah. And then your values would go from maximum, middle, minimum, middle, maximum. This is what the graph would look like, cos 2x. But we have to graph from 0 to 360 or 2 pi. So we need to keep going. And yeah, just keep going. And if I were to draw a horizontal line at -0.5, let's say -0.5 is halfway here. This function would equal -0.5 exactly at 4 different points. 1, 2, 3, 4. So in summary, you have 2 possible solutions for the period of your function. So if your period changes, then you have 2 solutions for that amount. So in this case, our period is 180 degrees or pi. So there's 2 solutions for the first 180 degrees or for the first section. And then there's another 2 solutions for the next 180 degrees. Since we're drawing this graph over a period from 0 to 360 degrees. Since there's 2 cycles, each cycle has a solution, has 2 possible solutions. So for this specific example, we're not done yet. We've solved for 1 set of solutions, which would be the first set of 0 to 180 degrees. Because we have 60 degrees and we have 2 pi over 3, which is, what is that? 60, 120, 120 degrees. Or pi over 3 and 2 pi over 3. To get the next set of answers, we just need to take our knowledge of the fact that these are periodic functions, and the period is pi or 180, and we can just add a period to any angle, and that will give us the exact same value. Just like, for example, if you have a regular function like sine x, and let's say you have 30 degrees. Well, if I add 360 to 30 degrees, I'll get 390 degrees, which is exactly the same thing as 30 degrees. 390 and 30 degrees are exactly the same because we're rotating in a circle. If I were to ask someone to rotate 30 degrees, or if I were to ask someone to rotate 390 degrees, they end up at the same spot. You don't believe me? Just try it out. So here, let's say this is our spot, rotating 30 degrees right over there. And then obviously this is like this. And let's say if I'm starting from here again, 0, and I ask someone to rotate 390 degrees. So 360 is going to be this much, and the remainder is 30 degrees. So that's just like that. We can add a period to any angle, and it'll give us the same value. So our period for this function is 180 degrees. So I can just add 180 degrees to this, 120 plus 180, and I will get 300 degrees, I believe. Or I can add, pi, 2 pi over 3 plus pi, which, remember, pi is just 1 pi, so it's the same thing as 3 pi over 3. So 2 pi over 3 plus 3 pi over 3 is going to be 5 pi over 3. Or 300 degrees. And the same thing here, I can add 180 to here, and I'll get 240 degrees. Or add pi to pi over 3, which is the same thing as 3 pi over 3, so it's 4 pi over 3 is the answer. Or 240 degrees. So there are 4 possible solutions for this specific question. All right. Good luck.